Oh, is Kent your father? I love that question. Kent, but wait, I've introduced him before, so the floor is yours. You can go up there or be there, whatever you do.
Well, I showed slides yesterday, so I don't think I will show any today. But I think I want to talk about the kind of mixed teams that we have, or the diversity of skills. First of all, at the Media Lab. So the Media Lab, for those of you who don't know, is actually a lab without a focus. There are now 22 groups at the lab, and if you are a group leader at the lab, you can really do whatever you want. So as a result, we have one group focused, called Lifelong Kindergarten, focused on children and learning and play, and but also focused on how adults can learn from play. We have a group called Biomechatronics, looking at high-tech prosthetic devices. Another group, Opera of the Future, thinking about music and technology and new types of performance, even how to compose music at the scale of the community where everybody can contribute. Affective computing, looking at how computers can understand emotions and react to it. And then our group is thinking about design and systems for the city. And I have found, I used to be in the Department of Architecture where more or less everybody thought the same way. By having this kind of diversity of experiences and almost total lack of fear of failure, which I think is essential, where people will just dive in and try things even if they don't know enough about it, and iterate very quickly. And I think in the end learn more than somebody that wanted to read all the literature and really get to know the field before they tried anything. I think it happens in a much more mixed up but more effective iterative way. I found that a much more creative place for me to do what I want to do. And somebody asked me yesterday, what are the skills within my own group? And I made a list. We have designers, but they are from architecture, urban design, industrial design, and human-computer interface design. We have engineers, mechanical engineering, electrical engineering, computer science. We even have a filmmaker who helps us think about the narratives and the scenarios. I have one guy with a dual degree in cognitive psychology and computer science. And we have a couple of people from the Sloan School who focused on entrepreneurship, and we have a sociologist. And I find this really exciting. We tend to get designers or people with a social background that know how to do some programming and have some understanding of technology, or we get good technical people that are sympathetic to good design. And in this mix, I think we can do things that we could never do if it was a much more limited set of experiences. So we don't think of it so much as multidisciplinary, or what's the title of this group? Transdisciplinary. I actually think of it as, you have to tell me what that means, Dick.
Yeah, no one knows.
I actually think of it as anti-disciplinary. I think of it, because I really do think I spend most of my time trying to break down the walls between the disciplines that people, come into the group with, and getting people to see that, programming and data visualization involves design, it involves thinking about people and sociology, and even when the students get down to writing a thesis, it needs to cover these multiple disciplines and bring it together. And it's not always pretty, making that happen. But I think it's important to deal with the kind of problems that are being discussed at this conference.
We're going to switch the order slightly here and introduce somebody who actually yesterday introduced himself totally and gave a brief bio, Don Norman, who said, "I'm one of those people we're talking about here," right? And didn't you say that? I think I'm quoting you correctly. He is director of the recently established Design Lab at University of California, San Diego, where he's also professor emeritus of both psychology and cognitive science. He was VP of Apple, and if I recall correctly, origin and roots go way back to course 6 at MIT, is that correct?
Yep.
See, we only invite people who really have MIT degrees here.
Yeah.
That's our secret. Don, floor is yours.
It is out of order because I said, no, I'm not going to prepare a talk. I like to reflect upon everyone else's talk, so I want to be last.
You keep that responsibility to somebody else, though.
Right. You know, I think it's time that the social sciences were first-class citizens. We all too much, was that going to be a clap, Paul? You can do it. Thank you. I've been doing a lot of work in automation. I started years and years and years ago. I've done a lot of work with aviation safety, with NASA Ames and the role that automation plays. And nowadays, I'm working with the automobile companies. I've worked with BMW, with Nissan, Toyota. And there's a real problem that in automation, the ASME has these wonderful, and actually the National Highway Transportation Safety Bureau has these wonderful levels of automation from 0, which is no automation, to 4, which is full automation, to levels 1, 2, and 3, which are the partial automations. And that's a stupid and bad and dangerous way to go. And I'm afraid that some of the researchers in these areas are going that way, but not the ones I've heard today, which is very reassuring. The problem with that is basically engineers automate what they can automate, and you leave the rest to humans. And in fact, as we're having automated cars come in and the states are starting to make rules about how you can have automated cars on the highway, one of the rules is you have to have a person sitting behind the wheel ready to take over when a problem arises. Bullshit. There's like 50 years of research showing that doesn't work. That we cannot, the better the automation, the worse it's going to be. Larson Bainbridge wrote this paper in 1958, and it's just as accurate as it is today. The more the automation, the worse our skills, because we don't have to do anything. We sit there for hours doing nothing, and so we're not paying attention. And on top of that, we're not driving, so our skills decrease. And then a problem arises, an unexpected problem. Two things we know about unexpected problems. One is they always arise, and second, when they do, they're unexpected. The driver says, huh? Now, this happens in aviation reasonably frequently. And when it happens, the pilots say, shit, what's going on? The pilots are really well trained, and the plane is what? 5, 6 miles up in the air, they have minutes to respond. And invariably they do. Occasionally there are some injuries to passengers or the airplane, but they almost always recover the plane. In the automobile, you have untrained drivers, and in 1 second at 60 miles an hour, you've gone about 90 feet. We need to change from this model to a different model, namely that of collaboration, cooperation. We should think of the person as a coroutine for you computer scientists. This is actually something we published at UC San Diego in the 1970s. Think of the person as a coroutine, and what are the capabilities of the person or the social group? And now let's make a system that takes advantage of the wonderful capabilities of machines, which are extremely accurate and precise and can repeat. And the person who is, we are not accurate. We are not precise. We can't repeat, and our attention always wanders. William James in the early, when was it, 1890, said that the average attention span of himself was about 5 to 10 seconds. That's one of our capabilities. Don't think of that as a negative. We're always scanning, we're always changing, we're always alert to all the things that are happening. But unfortunately, the machine world has forced us to behave like machines, which is the things we're bad at. When I see things that happen, accidents, and they're called human error, I say no. When you force people to act like machines, of course we don't do it well. So, I really loved Maja's talk, where she talked about the worst that robots, first of all, they need a personality. They should be personalized. And the goal of the robot is to enhance, not to replace. And I like Kent's talk because he said, look, we're going to bring together all the people, all the different disciplines. What I would like to do is actually get rid of the disciplines. I would love to change the university so we no longer have disciplines. What we should have is problems. Because when you have a problem, then the people with the necessary skills have to get together and work together and create together. And those skills will be everything. If you're going to have disciplines, well, then you know what? I think the social sciences, at least the applied side of social sciences, ought to be a part of the engineering discipline. Because, look, what are we building things for? We're building things for people. Don't you think we ought to understand people? And once again, not as the levels of automation, we'll do whatever we can and give the rest to you, but, oh, wow, yeah, people are creative. They can do the high-level strategic planning. They can change their mind when the circumstances, they're sensitive to the environment. Let people do that. Now let's make the machines do what machines are really good at. And I think as we go towards service systems, this is actually the real challenge. There's going to be a system. And at UC San Diego, we call it our work distributed cognition, and we're now trying to come up with a better name for that, which is basically collaborative human automation systems. And there are a couple of really good Department of Defense reports, and I was just recently at a National Academies Committee looking at just these issues. And the goal is we're going to have partnerships. There'll be people in many different places, distributed in time and space. There'll be groups, there'll be organizations, there'll be machines of various levels of intelligence and abilities. How do they work collaboratively? That's the real challenge. And I think that's the challenge for system science, because that's what the world is going to be. And I'm going to just leave you with one illustration. Some of you may have heard this, but it's always worth listening again. What's the best chess player in the world? Well, we know that IBM's Deep Blue can beat the best human player. But that's not the best chess player. The best chess player is a team of human chess players and machines. And mind you, these are the machines that you can buy off the shelf. They're not the world's best chess machines. And these humans are not the world's best chess players. I mean, they're pretty good, but they're not the world's champion. These teams can beat the world's champion, and these teams can beat Deep Blue. And that's an example of the kind of collaboration that happens when these people get together and they use the technology to enhance their abilities, but enhance them to not just world-class levels, to the top level. That's our challenge. Thank you.
Thank you, very inspiring. I'm sensing that the energy in this room here, we have one of those teams that we're creating right now. So hopefully we can follow that up over the coming months and perhaps years. Well, our last speaker is Calestous Juma. It's been my honor and privilege to get to know him over the past few months. He is an internationally recognized authority in the application of science and technology to sustainable development. He was named one of the most influential 100 Africans in 2012, 2013, and I'll let him tell you about the very prestigious award he just won about a month or so ago. Now, he has an appointment at the Harvard Kennedy School, but MIT and Harvard have this competitive relationship, so we're trying to steal him away. So this academic year, he has a visiting appointment in the MIT Department of Urban Studies and Planning, and he has an affiliation also with ESD. And we are most privileged that he's actually joined our research group and meets us for 90 minutes every Monday afternoon at 3 o'clock. So, and you can tune in to the BBC, their webcast network, which I think will contain the interview you had about Ebola yesterday, correct? No? 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 No. He's denying that. He knows nothing. He knows nothing about what I'm talking about. Calestous, the floor is yours. Oh, that was a secret. Forget it.
Dick, thank you. I don't have an MIT degree. So can I now leave? Thank you for having me. The only reason I show up at my talks is to act as a backup for PowerPoint. So I don't have any, but I brought something here that I'm going to call, it's a prop, but I'm going to call it a post-disciplinary device, in keeping with the spirit of our conversations here. And what I really wanted to talk about is, I wanted to build on the presentation earlier this morning by Dr. Transik on this phenomenon of exponential growth in technological capabilities. And when the first mobile phone was developed by Ericsson in 1956, it weighed 42 kilos. Not very useful for updating your Facebook status. What we have today is what I could describe as technological speciation. When you take a mobile phone used for communication in the Western world and you put it in an African context where they have other challenges. And with just very modest technological modifications, a mobile phone becomes a banking device and starts to create radically new industries, large-scale industries that never existed before. And so the industry of money transfer, which was born in Africa, as of last year, it was valued at roughly $18 billion. It's growing at around 82% per year. So the projection is that by 2018, the value of that industry will be $300 billion. But there are only two modifications introduced in a mobile phone. The platform for transferring messages or sharing messages, the SM messages, already existed. So a group of young people, when they were challenged to find a way of enabling farmers to repay small amounts of loans that you couldn't go from village to village in a Land Rover collecting $3, $4, $5 here and there. The UK government basically issued a challenge and said, can somebody come up with an idea that could enable us to recover the money without having to go there? And the young people knew that you could buy and transfer airtime. So they just reasoned that if you can buy and transfer airtime, airtime is acting as a currency. And they made that proposal, and that was the birth of the industry. The only technical modifications were to make it secure and to make it transparent. So the patents are essentially on those two functions. Everything else pre-existed. And so the biggest question that Africans are asking at the moment is, are there other areas of similar technological speciation as the money transfer, taking the same platform but applying it to different fields? And that becomes both a social challenge in terms of identifying existing problems, and then a technical one of being able to repurpose the phone to perform those new functions. And this is one potential application is just emerged as a consequence of the outbreak of Ebola in West Africa, in that when it happened, especially in Lagos, where there's a real effort on the part of the government and the state government to basically solve the problem. The governor of Lagos State did not want the word Ebola and Lagos to appear in the same sentence. So he mobilized every possible resources he could find. Just as a way of comparison, if you listed African countries by economic size and threw in Lagos State, it will be the fifth largest economy, it's 15 million people. And so the concern was that if Ebola spread in Lagos, it would be a catastrophe, not just for Lagos, but for the rest of West Africa. And one of the tools that was used was basically leveraging the capability of mobile phones to do contact tracing. So the government had to go and basically get a authority to basically access mobile phone records to be able to trace the various people who had been in contact with the doctors and nurses. And it was a massive effort that involved literally thousands, almost 100,000 visits to various people, taking their temperatures and monitoring their movements. And that has created a new interest in thinking about how you could repurpose the mobile phone, in this particular case, to serve as a medical device in a completely different context. And the link with the discussions here is that what became evident in Lagos particularly was the fact that the governor and the federal government, the leadership, was completely uninformed about what was going on. They didn't have the capability to make certain key decisions. And so the governor of the state of Lagos decided that he was going to appoint a chief scientific advisor to inform him on what was going on, to analyze trends, provide up-to-date information. But he didn't start with appointing a chief scientific advisor. He started with appointing a rumor manager. And I've never known anybody anywhere who has appointed a rumor manager, because there are so many rumors spreading around, a lot of misinformation. So the governor appointed a rumor manager to work with the churches so that they could basically suppress the rumors. And in a conversation I had with him, I said, you're having rumors because you have a gap of knowledge. Essentially, the leadership system is not smart enough to use existing knowledge. There's no mechanism for synthesizing the available information. A couple of months later, he appointed a chief scientific advisor. No African president has a chief scientific advisor. It started in Lagos as part of the learning process of the governor realizing that he needed to be updated on a regular basis on what was going on. And that brings really in this question of the extent to which we could leverage the capabilities of such devices to inform decision-making, not just to share information, but actually to inform decision-making. And I know many of you work on the committees of the National Academy of Sciences and Engineering. It takes up to 18 months to do a study. The committee members have to meet in person. Are there ways by which emerging economies like African countries, are there ways by which they could leverage such platforms to leapfrog the process of synthesizing information and making decisions? These are both institutional challenges of how you design new advisory methods through academies that work differently. And secondly, how you repurpose technical devices to be able to provide that support. I'm putting this forward as a challenge because I'm working with the new chief scientific advisor of the state of Lagos on figuring out whether you could have a new advisory system that could enhance the decision capabilities of the state by basically leveraging emerging technologies and not having to spend 18 months putting together a study. If Lagos was going through 18 months to put together a study on what to do about Ebola, they would never have solved that problem at all. But now we do have the capabilities, and that's really the connection with this phenomenon of exponential growth in science and technology. And this is not just in the area of health. There are similar discussions going on in regard to climate change, particularly in regard to agriculture, because of changes in ecological conditions across Africa. Some standard patterns of rainfall have basically fallen apart. Farmers cannot predict anymore when to plant. And so they need, in fact, up-to-date information which aggregates data from satellite imagery as well as what is being observed by local people to make different decisions on the timing of planting of crops. And in fact, this has led to a different conversation in another forum of actually starting to strengthen the ability of African science and technology academies to be able to provide that kind of information to governments. Next week, I'm going to be in Johannesburg to launch Africa's first Academy of Science, Agricultural Science and Technology. And one of the things that academy is going to be working on is thinking through how you leverage these emerging technologies to give better information, both to farmers, but also to leaders. And so I just wanted to close here by saying that there are opportunities that don't involve large-scale technological developments or even modern technological developments at the frontier of knowledge, but repurposing existing technologies to perform fundamentally beneficial functions in different contexts. And I think what we've seen with the mobile phone has the potential of being extended to many other areas of application, but also to create opportunities for collaboration between those who know about the technology and those who understand about the social problems. And thank you, Dick, again for inviting me here and letting me speak despite my academic limitations.
Well, we either get you at MIT in the front end or the current part of your career. So that we've got you now. See, Sergio, you have an official MIT payroll appointment, right? Well, we have time for maybe 2 or 3 questions. And if you have a question, please direct it to the panelists that you'd like to answer the question. So don't everyone stand up at once.
I actually have a question for Mr. Calestous. I worked for a few years in East Africa on a variety of public health projects, and there are many stories that we all know of wonderfully planned health projects failing because of rumor mongering. It's a real issue, and I'm so fascinated that there was actually a rumor manager. And I wonder if you could just say a few words about that and the role and the scope. Thank you.
Yeah, it's, after I finished my PhD, I set up a think tank in Kenya to inform government policy. And I was having a conversation with one of the senior government officials who told me that policy is that which you make in the absence of knowledge. That's how they viewed policy. When they say this requires a policy decision, that means you send it up and you rush it and you basically ambush the minister, and the minister makes a decision. You don't have to analyze anything. And I was trying to do analysis, but things have changed a great deal. I think the biggest change has been a shift in the composition of African leaders, in that you get more and more leaders who have come from a background of analysis, whether from the sciences or from business. And so, just to give an example, in the year 2012, there were 6 African countries elected engineers for president. And so it's hard to go to those presidents and just say, oh yeah, there's a rumor they're here, let's act on it. And I think it's that change in the character of leadership that is starting to select for greater interest in analytical input to decision making. There are now 15 African countries that have scientific academies. In fact, those academies work very closely with the NAS. And what we don't have yet is a receptacle in the offices of the leaders. You have the academies, they do some studies, but the presidents don't have a listening ear, which is basically a chief scientific advisor. And that's what I'm working on at the moment, is to get this Lagos case is really an interesting one, because you start to see that shift towards being evidence-based, away from relying on rumors. It's you can't get rid of rumors all the time, altogether, but at least we're starting to see an interest on the part of leadership to use evidence to make decisions. This academy that I'm involved in helping to create on agriculture, the request actually came from African presidents, not from the scientific community.
Thank you. Any other questions? Going once? Going twice?
Any rumors?
And the rumor is. Thank you very much, panel. We're now going to get set up for our last panel of the morning before our working lunch. And the chair is Professor Dan Burke.